So Avantika, let us try to understand this question. So again, see, one thing that I'm suggesting is, because when we do these questions from JE, what happens is we understand, come to know a lot of new points and techniques to solve a question, and those techniques we might use in other questions. Have you understood what I've said?
Yeah.
So a helicopter rises from rest. Underline, you have to underline this, from rest, because what this implies is that the initial velocity of the helicopter is zero on the ground vertically upward with a constant acceleration of g. Now, when this helicopter has an acceleration g, you have to focus on this acceleration g, not the Earth's acceleration g. Have you understood?
Yeah.
So when the helicopter is rising up, because you are sitting in the helicopter, you will be focused on uh, the acceleration of the helicopter, which would be in the positive direction. Now, you have
Hmm.
to, you don't have to focus on this g, which points down and it is usually taken as negative. Have you understood what I've said?
Yeah.
Because you are sitting in the helicopter now. A food packet is dropped from the helicopter when it is at a height h. So this helicopter, so for example, if this is the ground and this is the helicopter, so at this point when the helicopter is h meter above, then the packet is dropped. Have you understood?
Yeah.
Now what you need to understand is that this packet was part of the helicopter. So whatever velocity the helicopter had, the same velocity this packet would also have at this point P, where this packet is released. Is it making sense?
Yeah.
Till this point, till this point, the packet had a velocity, had an acceleration g. But once it is set free, now it will be falling like this. Have we understood this?
Yeah.
Any doubt till here?
No.
Okay. The time taken by the packet to reach the ground is close to. Okay. Now this problem is, what we require is that this packet was set free at this point, at at this point. Now from this it will reach its highest point. From its highest point it will come down, and then it will keep following. Is it making sense, Avantika?
Yeah.
Okay. So our job is, specifically, our job is to find the velocity of the packet when it was at this point. Is it making sense?
Yeah.
The velocity of the packet and the helicopter would be the same at this point P. Then the final velocity, basically, I will be uh, calculating 3 time intervals to find the answer. This, I will be breaking the problem into 3 intervals, T1, T2 and T3, where T1 would be equal to T2. Why? Because the time the packet takes to go up is the same time it takes to come down at the same point. Avantika, is it making sense or not?
Yeah.
This T1 and T2 is same. So once I have
Hmm.
found T1, basically my T2 is found. Is it
Okay.
clear?
Yeah.
Second thing that I will be using in this problem is, there are two things that I'll be using. One, so for example, if you throw a ball up, the time it takes to reach the highest point, this time, is the same that it takes to come back to its original point. Is it making sense?
Yeah.
So T1 is always equal to T2, and if you want the time of flight, the time of flight is T1 plus T2. Is it making sense?
Yeah.
The second fact that I will be using is, because I'm neglecting friction, I'll be neglecting all losses. So the velocity at this point would be the same as the velocity at this point. Is it making sense?
Yeah.
So what I'll be doing is, first I'll be calculating this velocity. What is the velocity of the stone, of the packet at this point? It will be going till this point. Then from this point to this point, it will come back again with the same velocity. And then from here to here, it will be falling down. Is it making sense?
Yeah.
Okay. Now, this may seem a bit complicated, but once you focus on the concepts, then the things will become very clear. So this is my helicopter at point P. This was at height above. So at this point, it has released the packet. Is it making sense? So initial velocity of the helicopter was 0. We want the final velocity. This is at point P. At point P. This is my point P at this point. This is where the packet was released. So at this point, the height is h. Is it making sense? Avantika, are we clear till here?
Yes, sir.
So I'll be using this equation 2as is equal to v square minus u square. So 2g. Now again and again what I am specifying is you have to focus on the acceleration of the helicopter, not acceleration due to gravity, as long as the packet is in the helicopter. So 2gh would be equal to the final velocity of the packet when it is released. Is it making sense?
Yes.
So the packet basically is released from the helicopter with this velocity. Is it making sense?
Yeah.
So at this point, the velocity of the packet is root 2gh and the packet is going up. Is it making sense?
Yeah.
Now I'll be analyzing. So this point P, basically when I was doing the question, I had named this point A. So don't worry about that. So AB is the duration where the packet is going up. This part. Now I have the initial velocity as a root 2gh. The final velocity is 0. Now the acceleration due to gravity will start playing a role. Have you understood?
Yeah.
So this t that I've calculated is basically my t1. This t1. And this part is my part AB. Is it making sense?
Yeah.
So T1 would be V minus U minus root 2GH, and the basic mass I've used, so this would be 2H upon G. Is it making sense?
Yeah.
So this time T1 would be equal to my time T2. Basically, this time that the stone is going up would be the same as the time that the stone would be coming back to this point C. Is it making sense?
Yeah.
Now the stone has come back with the same velocity at which you had released it. Is it making sense?
Yeah.
And now we want the time 3, which is from C to D. Is it making sense?
Yeah.
Now here what I have done is, to make things easier, what I have done is I have used the conservation of energy principle to make things easier. We know that at point C, if you look at point C, the packet has a potential energy mg8 and has a kinetic energy of half mv square. Is it making sense?
Yeah.
So v square is equal to root 2gh square, which will be equal to 2gh. Is it making sense?
Yeah.
So this is the basically this part is the total energy at point C. Is it making sense?
Yeah.
And this part is the total energy at point D. Is it making sense?
Yeah.
Why do I want this? I want this because I want to calculate the velocity with which the packet will hit the ground, Vd. Is it making sense?
Yeah.
And why do I require Vd? That you will understand in just a minute.
Okay.
So using conservation of energy, I calculate Vd. So you have to trust me on this, that when you solve this, the answer of Vd that you will get would be 2 root gh. Is it making sense?
Yeah.
Okay. And now you will understand that once I have this Vd and I have this velocity, so this would be my initial velocity, this would be my final velocity, my acceleration is g for the packet which is coming down. So I'll be able to calculate my T3. Is it making sense?
Yeah.
So T3 would be equal to final velocity, that is 2 root gh minus root 2 gh upon g, and then I simplify this. This would be 2 h upon g root minus 2h upon g. Again, you will have to trust me that this calculation is okay. Are we clear till here?
Yeah.
Okay. So now I have got my T1, T2, T3. These are my T1, T2, T3. I just have to substitute the value of T1, T2, T3. So this is my T1. T1 and T2 are the same. And this is the calculation for T3 which I had done here. Is it making sense?
Yeah.
When I do this calculation, what I'll realize is that there will be two fellows which will cancel. So this and this will cancel, and I will just be remaining with this. And from here I can take root h upon gs common, root h upon gs common, and I'm left with root 2 plus 2. Is it making sense?
Yeah.
Now what you need to know is that the value of root 2, you should remember this, is 1.414. But I need value of root 2 as 1.4 only. So 1.4 plus 2 is 3.4. So 3.4 root h upon g is my option number C. Is it making sense?
Yeah.
What I'll suggest is, this is my option number C. What I'll suggest is that do this question again. You can,
Yeah.
I'll upload the solution, that is not an issue.
Okay.
So just do this question again so that you understand the concepts which I have used here. Is it making sense?
Yeah.
Because specifically what I have used is that the time of flight while going up is the time of flight while coming down. The total flight of time is you add both these. And another concept that I have used is the conservation of energy principle, where I used mgh plus half mv square was equal to half m v1 square. So this was the velocity that I calculated. Avantika, is it making sense?
Yeah.
So try to do this question again using the concepts that we have discussed.
Yes.
So let us meet tomorrow at 5. Yeah.
Okay, sir.
And tomorrow when we meet, because then rest of the questions are simple. Then we'll they are relatively simpler questions. We'll be able to cover these in 1 hour tomorrow. Yeah.
Yeah.
Okay. Tomorrow 5 p.m.
Yeah. Okay, sir.
Okay.
Thank you.